Welcome to Brain Vision.
So here on this problem we are given this two-stage rocket, and the second stage carries fuel of mass 1200 kg and the mass of the empty rocket is 200 kg. Now the fuel is burned at the rate we are given to be as 5.2 kg per second, and the exhaust velocity u we are given to be as 3000 meter per second. Now we have to calculate two things. First, the acceleration of the rocket after 60 seconds from the ignition. So we have to calculate the acceleration after 60 seconds and the maximum acceleration. So these two things we have to calculate, and for that I will be first let me first show the forces on the rocket. So this would be the mg force that would be acting in the downward direction, and we will be taking this direction as our y direction, positive y axis, and acceleration is like this for the rocket. Now to solve this problem we will be using the variable mass approach. And by using this approach we can write that net force sigma F in the y direction will be equals to m dot u plus m v dot. Here m dot is the mass flow rate, basically this is the rate at which the fuel is burned, and this m is the mass, total mass of the rocket at the instant we have to calculate the acceleration. So mass would be equals to 200 plus 1200 minus, now the mass is being reduced since the fuel is burned at the rate this much. So for any time t, the total mass of the rocket would be this much. This expression would tell the total mass of the rocket at any time t. Suppose if you want to find the time at t equals to 60 seconds, so we can plug t as 60 here and we can find the mass of the rocket at that instant, and so on. Now m dot will be equals to negative m dash because fuel is being burned, and it is equals to minus 5.2 kg per second. Now we can put the values in this formula. Now sigma Fy, we have only one force in the y direction, that is mg, and that too acting in the downward direction, and we have taken positive as in the vertically upward direction, so we have to take this force to be negative. So minus mg, I'm just putting it here, is equals to, now m dot, so m dot we have negative m dash, which is minus 5.2 times u. So u we have 3000 plus, now this mass can be written as this much, this is the mass, so which is 1400 minus 5.2 times this v dot means the acceleration. So rate of change of velocity is acceleration, so we can write v dot as a. We can put the values. Mg we can put it as this much, so 1400 minus 5.2 t times g is equals to, this would become minus 5.2 times 3000 plus this one as it is 1400 minus 5.2 times t multiplied by a. Now we can put the values. So 1400 as it is minus 5.2 times t. Now this time t is the time at which we have to find the acceleration, which is 60 seconds, so we have to put t as 60 seconds here, times g is the acceleration due to gravity, which we are given in the equation to be 8.70, is equals to this one as it is 5.2 times 3000 plus this one would be 1400 minus 5.2 times 60 seconds and multiplied with acceleration. So from here we can easily calculate the acceleration a, and it comes out to be as nearly 5.64 meter per second square. So this is the acceleration at t equals to, or you could say after 60 seconds from the ignition. So this is the acceleration of the rocket. Now next we'll be calculating the maximum acceleration. Now to calculate the maximum acceleration, we have to first calculate the time at which it occurs. So initially we have 12 kg of fuel. If this fuel is burned, total fuel is burned, so at the instant when the total fuel is burned, at that instant the acceleration would be maximum. So we can write that 5.2, because at this rate the fuel is burning, times t, it should be equals to 1200. So from here t comes out to be as 231 seconds. So at this second the acceleration would be maximum. So we can put the value of t here in this formula, in this equation that we derived earlier to calculate the acceleration. So let us put the values. So this is 1400 minus 5.2 times t is in this case it would be 231 times g is 8.70 is equals to minus 5.2 times 3000 plus this would be 1400 minus 5.2 times t would be 231 times the acceleration. So from here the acceleration comes out to be as nearly 69.3 meter per second squared. So this is the maximum acceleration of the rocket that was asked in the question. So I hope you have understood the problem. Thank you.